Chapter 10, Section 10.1, question P9, and we have another confidence interval. This one also 95%, and the interval is for a population mean. Notice that we can have a interval for proportion or something too if we want, but this is for a population mean, and we have a random sample. The confidence interval that we have is from 43 to 47 pounds, and we're just saying true or false on some statements. So first of all, 95% of the weights in the population are between 43 and 47. Kind of makes sense putting a couple numbers together, but in fact, look at the actual name for this confidence interval. It's the 95% confidence interval for a population mean. So it doesn't tell us anything about where the actual specific individual data points are coming in. All it's telling us is the population mean itself. That's what we're really trying to estimate. So using our sample, we're coming up with an estimate for that parameter, that population mean. We don't know anything about the individual weights. So this is not a true statement. 95% of the weights in the sample, this is also false. So even though we do have access to the entire data of the sample, which we don't for the population, it's still not telling us about those individual ones. It's telling us as a whole for the specific statistic that we're calculating an interval. In this case, it's the population mean. So both A and B are talking about specific points in the sample or population, data points, and that's not what this is telling us. The probability that the interval includes the population mean is 95%. Now this one, boy, that looks tempting because we are talking about a confidence interval for a mean, and this is what looks like we're being asked right here. So why isn't this correct? This one's a little more subtle. So probability of something happening, the actual probability that the population mean is in our specific estimate here, our specific confidence interval, it's either 0 or it's 1. It's either inside that, in which case it's 1, or it's outside that range, in which case it's 0. Those are the only two possibilities for the actual probability. Now what we could say is we are 95% confident that the interval includes the population mean. So that level of confidence is something that certainly can vary anything between 0 and 100%. But the actual probability is either 0 or it's 1, depending on whether or not we got it. And notice, we have no idea. I mean, we would have to be, one, either God or some higher power to know this, or we would have to know data on the entire population, which is very rarely the case. So that's why we call it a confidence interval instead of a probability interval. The sample mean might not be in the confidence interval. Now you would think might not be, I mean, yeah, there's a chance it might not be. It's false. Why is it false? Because it's talking about the sample mean. The sample mean has to be inside our confidence interval because we create the confidence interval around the sample mean. If you remember the formula, let me flip back to one that we had used before. The formula is based on the sample mean plus or minus this value, and this value is never negative. So if we're adding some to this mean and subtracting some around it, we have to capture the sample mean in there. But that's not really important. The population mean is what we really want, and that is true that it might not be in the confidence interval. And finally, if 200 confidence intervals were generated using this process, about 10 of these would not include the population mean true. If 100 were generated using this process, about 5 of them would not. 95% confidence also means 5% chance of error. And specifically, it's called a type 1 error as we get into hypothesis testing. But by setting that 95% confidence, we're also setting the 5% error rate. 5% of 200 is about 10, or it is 10, but we don't know we'd get exactly 10. Just about 10 would really not include. In other words, this 43 to 47, 10 out of 200, if we got something like this, are going to end up being 42 or less, or 48 or more. So this confidence interval also tells you about the doubt interval in a sense.